In this video, I'll talk about differentiating non-inverting and inverting amplifier, and then just take a screenshot. Okay, if in the future you lost this text document, at least you can know where am I now. Okay, so this one also take, and then this one also take, and then yeah, that's all. So these are the things that describes the video on here. Okay, so as you can see, if I want to go to like op-amp buffer, I can go to 950 of like 9 minute 50, and then I can straight away know what is buffer and such. Okay, so I'm not gonna go through this one, but just let you know that in the future you may actually need it. Whatever. So let's continue with differentiating non-inverting and inverting amplifier. Because now we talk about so many MP thing, right? Class A, Class B, whatever thing. So all these things when you do it up, when you merge them together all like this, you get a advanced amplification. Okay, you call it an operational amplifiers, which is this one, this dude over here. So all these things is inside here. I think only. Yeah, I think so lah. So these are all these things. So wherever MP thing is all put into here, and then you just have a magical thing, and then you get the op-amp inside here. So after which, these are the two. This is the plus V and supply. This is the supply positive and supply negative. So you supply the voltage in, you supply a voltage in the negative or positive. That's all. And then I'm not gonna go through this. Later maybe whatever you can see inside the tutorial notes lah. Then what other stuffs? I can just talk about a little of this lah. So this is the op-amp, right? Comparatively, this one and this one is one input, this one is two inputs. Okay. So what are the differences and why is it normally used? This one is actually a comparator op-amp. Okay, you're comparing this input to this input. So input 2, maybe you can take you take this you take this one minus this one. Okay, you take this one minus this one, and then you multiply by whatever gain. Okay, there will be some gain. Later we'll talk about it. So you can actually have an output over here. So let's say you have an input 2. Okay, this is plus. So positive is actually input 2. And if it's this input is 2.5, right? If this input is 2.5, you minus away the V in, the V minus. So this is this. So this one minus this one. So I'm taking this one minus this one. So 2.5 minus 0, I have 2.5. Then if I have a gain of 5, if I have a gain of 4, 2.5 times 4 will be 10, right? So this is what it is. Okay. So the gain is actually, as you can see, 1 minus 0 is equals to 1, right? So 1 times something gain is equals to 4. So definitely the gain is equals to 4. So from this, I can deduce that gain is 4, and then I can multiply, and then I can complete the table over here. So this may also be a question in the exams, I don't know. But it's certainly something you may need to know. Okay, if you happen that you forgot in the future, but yeah. So this is the thing that I'm talking about just now, right? This is the amplifier. I mean this is the op-amp. So when if you connect the op-amp like this, okay, you only have an open loop system. Okay, let's say you have an input of maybe 5 volt. Okay, so you have an input source lah. Okay, and then you have another whatever source, maybe some reference lah, maybe 4 volt. So yeah, so this is the open loop circuit actually. So in the op-amp, this is actually a comparator also. So you can take 5 volt minus 4 volt, you get 1 volt. Then multiply by gain, you get some values. But nonetheless, this is not a good amplifier because there is no feedback system. For an op-amp, you would want this portion and this portion to be the same, right? If this is 5 volt, this must be 5 volt also as a comparator in order to what? Yeah, if this is 5 volt, this is 5 volt. Okay, these are the standard configuration where you never plug in anything. Okay, let's say this is a system. Okay, if you plug in the supply, okay, you definitely maybe a supply is another, maybe some other 10 volts or whatever, and then you apply the supply, and then you change and then you may need to feedback in order to change certain things over here, in order to change this thing into certain other volts, so that you can actually have a gain, you know, you can actually have maybe some resistors also lah. Okay, later I'll talk about it, the non-inverting and inverting amplifier. But nonetheless, you would need a closed loop system in order to amplify certain things. If otherwise, you cannot amplify anything at all. So in this case, this dude over here is actually a useless op-amp. Okay, this is just used to give you an overview of what is an op-amp itself only. So nonetheless, if you were to connect in a closed circuit, okay, closed loop, and then without any resistors at all, okay, if you connect into the so this is the inverting, and this is the non-inverting input. This is the inverting input, right? If you remember. So this is the inverting, this is non-inverting. So if you were to connect in this manner, okay, you will get a buffer. The buffer is simply is to isolate the input lah. Okay, this is what the definition says. If you go to your tutorial, okay, it says that if you were to go to question 8, I think, question, not record it. You're gonna go to this one, question 6. So its purpose is to isolate the components from the input. Okay, so the components may be somewhere other place. So these are the inputs. So you're gonna isolate the input from other components. But nonetheless, from the video that I showed you earlier, the EV block, this one, yeah, whatever. If you were to take a look from the op amp itself, it says that you can actually, because at this point of time, the input itself, let's say this is the input, maybe 5 volt. The input voltage, because the op amp itself, there is 2 rules. Okay, the first rule is always the rule is that the op amp will never take in will never give or take in current. Okay, so the op amp itself will never take in any current, or you'll never take in or give out any current. So you always be itself. But however, this is the ideal case lah. For a non-ideal case, and may take in certain current. But nonetheless, in this case, for example, if this is the voltage in, right? So the current actually flows if there's another thing connecting to here. The current will actually flows in this direction, into here, and then it goes out. You will not flow into this op amp. Nonetheless, this one will not flow into this op amp. It will just flow in this direction, or whatsoever lah. Okay, whatsoever. But nonetheless, just need to remember that the buffer isolates the component from the input, and then it also changes the high impedance of the input to a lower impedance, so that it can actually give out more stuffs, more voltage or whatever lah. Okay, but then not sorry, you will not give out more voltage. Okay, if you have a 5 volt over here, you end up you have a 5 volt over here. You will not change anything. There's no gain. Okay, but nonetheless, you allow smoother signal things to come out, I think. Anyway, whatever. So if I have a non-inverting, okay, so I have been talking all about the nonsense. I mean, you may not understand all this, but anyway. So if you have a non-inverting amplifier, I'm gonna input a voltage of 5 volt, or maybe some other volts lah. Okay, some input. Okay, some input voltage into here, while the this one, while you're referencing to a, so there'll be a closed loop system over here. Okay, there'll be there'll be 2 resistors. We call it R2, we call this R1. Okay, and then this one will be grounded. Okay, so you are referencing to ground. Okay, so this is the non-inverting amplifier. For inverting amplifier, there will be 0 volts over here. Okay, there will be no input. However, the connection is still the same. Okay, there will be an R2, there will be an R1. However, in this case, there will be a voltage, maybe 5 volts. Okay, so in this case, this is an inverting amplifier, this is a non-inverting. The only difference is that non-inverting, you are inputting a input voltage into the plus sign. Okay, if it's inverting, the plus sign is 0 volt, while the minus sign is an input, and then you just connect another power source from here. I mean, yeah, not supply lah. Supply is here lah. Okay, I'm not gonna talk about that. And then yeah, so nonetheless, if you see that maybe this is some input, right? If you see that there is another this one grounded, this is also non-inverting because certainly there is still certain input into the plus sign, into the non-inverting sign, so that's why it is still a non-inverting. The grounded is simply to protect the system, that's all. Okay. So similarly, if you have a 5 volt over here and then you have a certain grounding again, so this is actually like no problem also. So this is still inverting. Okay, so these are the things that you may need to like take note of. And then the governing equation for non-inverting is R2 over R1 plus 1 equals to, they call it AV. Okay, so it's not like AV, but it's like gain. Okay, so this is gain. So the gain itself, yeah, so you amplify the gain. So let's say you have a difference in voltage over here. So you multiply by this gain, you can actually have an output voltage. You can calculate it already. Okay, so in other words, if I have maybe I have 5 volt over here, I have 2 volts referencing. Okay, and then if I were to if this is 10 and this is like 2, okay, so calculate the output voltage. So this is the question now. Okay, so what do I do? So first I need to calculate the difference between the input voltage and the referencing voltage. There may be some referencing voltage over here lah. Okay, so 5 minus 2 is equals to 3, right? So this is 3 volt. So you need to multiply by gain also, right? So the gain is R2 divided by R1. So 10 divided by 2 plus 1 is equals to 6. So this is a 6 gain. So 3 volt is the difference between them. Okay, it's a difference between them. And then 3 times 6 is equals to 18 volts. So the output voltage will be 18 volts. So these are the things that you may need to really take note of. So this is for only non-inverting lah. Okay, for inverting in this case, the formula is actually R2 over R1, and then it should be minus. Okay, but nonetheless, the gain itself is just simply saying the gain and the magnitude of the gain. So in the text in your PDF is always saying gain is positive. Or however, if it's outputting, it's actually creating a negative gain. Okay, so these are the things you need to take note lah. You're gonna invert. So in a graphical way of drawing, because they may actually ask you to draw out the graph of a inverting and non-inverting. So hold on. So for non-inverting, right, it only amplifies the signal. Okay, you didn't change the phase, you didn't do anything. For inverting in this case, you actually have a inverting signal over here, right? Nonetheless, you may actually amplify the inverting signal, so you may actually have a higher voltage. That's all. So these are the two things you may need to take note of. So yeah, and then what do I do to do? Before I end, just want to let you know the crossover distortion. Actually no lah. Okay, so this is class A. Never mind. I'll stop here. So this will talk about non-inverting and inverting. The differentiating part is actually where you put your voltage. That's all. If you put your voltage in the positive side, you have this one. You have non-inverting. You have a certain input voltage. You are into the negative side. You have inverting. But nonetheless, this circuit is always the same. This closed loop is always connecting to the negative side. Okay, this closed loop is always connecting to the negative side. So I'll see you in the next video for other stuffs.